Okay, here I'm talking about simple and also compound interest, which I will involve the example of a growing or reducing populations. It can be either populations or car value or asset growth or investment values. Okay, this all will be included in a simple and also compound interest. Okay, now look at the first one. You have invested up to 10,000 in a bank, which gives you 4% per annum as an interest. So calculate the total amount, include the interest for 25 years with simple interest concept. Okay, here, step 1, we just have to calculate 4%, 4% of the 10,000. So which means 4 over 100 times with the 10,000. So we'll be getting about 400 a year, okay, per annum. So this is for 1 whole year. Okay, now if simple interest means the interest money that you are getting here will never change. Okay, so you'll be getting 400 for the continuous 25 years. So which will be getting about $10,000 as a interest. So you can plus with your initial investment, which is a 10,000. So this is your initial model or capital, your first, and your total after 25 years you'll be getting about 20,000. Okay, so remember, this is a simple interest. I'm going to use the same concept for compound interest. Okay, this is the same value, 10,000, which gives you about 4% per annum, and 25 years with a compound interest. So now let us recalculate again the previous one. Okay, so here you have 4% of the 10,000. So which means you'll be getting the same 400. Okay, and this is for the first year. This is the year 1. So I can call it as a end of year. Alright, so this one will be plus with the initial investment, which is at 10,000, and they will bring it to the second year. Now let me do a table for you so you'll understand much more better. Okay, here. So now this is the year that you have invested, the first year. Interest is the same. Okay, interest is stick at the 4% interest, and your interest is about 400 from the calculation just now. Okay, now the end of year, together with your investment, you have about 10,400. Okay, now in your second year, what will happen here is you are going to multiply with this. So which means the 4%, okay, the same 4% will be multiplied with 10,400 instead of the 10,000. So you'll be having 416 for the second year, and we'll add on to your initial model. So model for the first year is 10,000, second year is the 10,400. So when you add up the end of the second year, you'll be getting about 10,816. And if you continue over here, number 3, the third year, so which is 10,816. So the same interest, 4 over 100 multiply with 10,816, you will be getting you'll be getting here 432.64. This is your interest for your third year, which then I will add on with your model here, and I'll be getting 11,248.64. Okay, so if let's say if I ask you to calculate up to 25 years, we cannot be doing like this for 25 times. So we have a formula for this. So let me introduce you the formula. Okay, now for the formula, this is your final value. Final value equals to, this is the initial amount. Okay, initial amount multiply with 1 plus or minus. I'll explain to you why is it minus. And then here I'll have the interest over 100 and power of the year. So here you have interest, and this is the number of years, and plus is for something that is accumulating. Okay, minus is something, for example, you have a you bought a car for 100,000 and you are going to sell it for after like few years, and the value will be depreciating. So when it is a depreciating, we are going to use negative. Okay, now let us use this formula. So now we have about 10,000 multiply 1 plus, we are going to use plus over here because this is an investment. So it's about 4%, 4 over 100 and power of 25. So I like to simplify the inside the bracket here. So it will become, this is 0.1. So 4 over 100, you'll be getting here about 0.04. Plus with 1, you get 1.04 power of 25. So if you include this in your calculator, we will be getting here about $26,658.36. Okay, so this is the final value of your investment. So this is by compound interest. So if you compare with the first one, our simple interest here is only about 20,000, but with the same amount of money, we are going to get 26,000 with compound interest. Okay, so I'm going to use this formula to continue with the next question. So the next question will be example. Okay, now Japan has a population of 64 million people, and their population is reducing at the rate of 6% per annum. Okay, in this case I'm going to use minus over here because it is reducing. Okay, so I'm just going to put here about 64, and million I'll skip it first. This is for the simple calculation. And then I'm going to make 1 minus 6 over 100, and then here will be power of 5. So simplify inside the bracket, you'll be getting here, this is 0.06. So you'll be getting here 0.94 power of 5. So you'll be getting your answer about 47. Okay, 47 million. It's supposed to be 46.96. So I just make it as a round figure. Okay, so this is how we are going to use compound interest. So now I have another examples for you. Okay, this is a past year questions. Okay, this is, okay, now we have, okay, ZA invested 500 at the rate of 2% per year, simple interest. So we just have to calculate 2% multiply with 500. So you'll be getting here about $10. So this $10 is for per annum. So value of ZA investment after 5 years. So $10. This is only the interest here. Only the interest. Multiply with 5. So this is 50. So this is only the interest money. Okay, this is only the interest, and plus with your initial model here, so we have total about 550. Okay, now we go through back another question. Okay, so here we have 500 at the rate of 1.8, but this is a compound interest, so we can use this formula. 500 multiply 1 plus 1.8 over 100 and power of 5. Okay, so we are going to have here okay, I have simplified this. Then power of 5 and multiply with 500, you'll be getting about 546.65. Okay, so this is your investment. So if you look at here, okay, ZA and also Yasmin continue with these investments. ZA is a simple interest guy, and this is a compound interest. So which many more complete years it is before the value of Yasmin investment is greater than the value of ZA investment? So we can use a try and error over here. Okay, so this is the complete working for both of these question. Okay, so to answer this question, so either ZA or Yasmin, so which one will be higher? So I come up with a formula. This one will be multiplied with the years, 10. So here we have like a 10 n for the number of years, and this n for the number of years as well. So we just have to play around, just substitute these values. Okay, substitute these values. So let us try 6. Let us try with 6. So okay, this one should be plus. This one should be plus. So let us try with 6. So here you got 60, and then here we try with 6. So we got here about 556.49, and here you are getting here about 560. So it's quite close. Now let us try for maybe about 7. So it becomes 70. Okay, and here also we substitute with 7. So we are getting here about 566. So it's quite close. So let us try 8 now. So we have here about 580, and then here we try 8. It's quite close. Okay, now let us try with number 14. Okay, number 14. So now we have here about 140, and here we got about 640. So we replace this with 14, and we'll be getting here about 641.85. So at the 14 years, after 14 years, Yasmin's investment has overtaken ZA. Okay, this is the beauty of a compound interest. Okay, for this type of questions. Now let us try a bit more complicated questions. Okay, now Xavier buys a new car for 2,500. The value of the car decreases exponentially. Okay, so now we have to use 2,500 multiply 1 minus. Now look at the interest is 10%. End of the 5 years. So we just have to calculate this. This is 0.9 power of 5. So when we are calculating this, I'm going to get here about 1476.23. Okay, so this is your answer for this. Now we look back. Okay, this question is a bit not to say hard. They ask us to find the R value. Okay, the number of certain type of bacteria increases exponentially at the rate of R each day. So after 22 days, the number of these bacteria has doubled. So find the value of R. Okay, in this case, we just have to use final value equals to initial. So here we have like R percentage. Okay, then after 22 days. So this one, we are going to use it for days. So it's like 22. Okay, now since they have mentioned doubled, right? Doubled. So we divide first. So this is the working. And then when we divide, we are getting here a 2. It can be like 10 and equals to 5. So the 5 will move there. So we got here about 10 over 5. So we are getting here about 2. Okay, now there is a small hint I'm going to teach you how to solve this type of question. Now look at here. When you have a power of 3, the 3 will move there, becomes 1 over 3. Right? Okay, so we are going to use the same method over here. So here you have 2 power of 1 over 22. Okay, 1 over 22. So now, when we are calculating this, I get here about 1.032. Okay, then we just have to find the R value. So 1 we have to minus that. Oh, sorry, it's plus. Okay, so here you'll be getting 0.032 R over 100, and 100 will be multiplied over here, and you'll be getting there about 3.2%. So this is your R value. Okay, so that's all for this chapter.